Now we go for RMS value. What is RMS value? Means root mean square value. Root mean square value. RMS value is nothing but root mean square value. Now what is the definition of RMS values? Normally the current is measured, the current I is measured by the amount of work it will do or amount of heat produces. Heat produces. The RMS value depends on what is the amount of heat produces. Based on that RMS value is defined. The RMS value of alternating quantity is given by the steady current. Steady current means DC current, which when flowing through a given circuit for a given time produces the same heat as produced by alternating current when passing through same circuit. When you consider AC current and DC current, when you consider AC and DC currents, two currents producing same heat when passes through a circuit. The RMS value of alternating current is given by steady or DC current when flows through a given circuit for a given time producing the same heat as produced by alternating current when flowing through the same circuit for the same time. It is the definition of RMS value, root mean square value. It is also known as virtual value. It is also known as virtual value. It is also known as virtual value or effective value. Effectively means it producing heat. Effective value it is. The RMS value of alternating current is given by steady current which when flows through a given circuit for a given time produces the same heat as produced by alternating current when flowing through same current, same circuit for the same time. Now what is the RMS value? Symmetrical waves, the RMS value is same for both half cycle and full cycle. For non-symmetrical waves, the RMS value should be determined for full cycle. For half cycle, if a symmetrical means when you join this waveform, if you consider this is the waveform symmetrical, it is a symmetrical wave. For unsymmetrical wave, we have to consider both cycles. For RMS value, root mean square value can be calculated by using one formula. RMS value is root mean square value. It is square root of area of squared wave divided by base length. Its base length. Area of a squared wave divided by its base length. Already we calculated average value. Similar to that, we can calculate root mean square value. Consider a sinusoidal waveform I equal to, the sinusoidal waveform equation is given by I equal to I max sin omega t. I max sin theta or sin theta is known as omega t. Theta equal to omega t, since we can write. RMS value of instantaneous value of current over half cycle only we are considering. Half cycle only we are considering because it is symmetrical. For unsymmetrical full cycle we have to consider I max sin theta. This is the current equation already what we derived. Previously we assumed for average value what we assumed. The same we are assuming for this, that equal to square root of area of squared wave, that is integral 0 to pi I square d theta. Area of one squared wave I square d theta by base length is pi minus 0. Pi minus 0. If you do integration with the square root is applied for both. That equal to square root of 1 by pi integral 0 to pi im square sin square theta d theta. Because since I equal to I max sin theta, we are substituted here. We have to consider I square. I square is the losses produces heat related, the RMS value is, hence we have to consider I square d theta. We can write this equation like this. This pi will come here, 1 by pi. I in place of I square we can substitute Im sin theta. We can obtain like this Im square sin square theta d theta we can obtain. Since sin square theta equal to 1 minus cos 2 theta by 2. We can write sin square theta equal to 1 minus cos 2 theta by 2. Substitute that here, that equal to, now move this into out of integral im square by pi, im square by pi, integral 0 to pi, that is 1 minus cos 2 theta by 2 into d theta. We can write like this. Now do the integration of this. If you do the integration of this, square root of im square by pi minus sin 2 pi. If you substitute the limits and do the integration, pi minus sin 2 pi by 2, it is 2 minus 0 sin 0 degrees by 2. It is another one by substituting the limits. Now we can write like this. After that we can, that equal to square root of, that is square root of im square by 2 pi minus 0 minus 0, that equal to im square by 2 pi into pi minus 0, I can write pi, this is pi get cancelled, that is im square root of, it is im square by 2. We can write as im by root 2. This is the RMS value. IRMS value is given by I max by root 2. If you remove the root, im will come. After that we are dividing with root 2. This is known as RMS value of alternating quantity, IRMS. Similarly, we can write VRMS also. VRMS equal to Vm by Vmax by root 2. That equal to, what is the 1 by root 2 value? 0.707 Im. It is also known as 0.707 Vm, Vmax. Similarly, what is form factor? Based on RMS value and peak value, average value, what are the various factors? One is form factor. Form factor is defined as, it is a ratio. Form factor is one of the ratio. RMS value to average value. RMS value divided by average value gives form factor. Form factor is denoted by Kf equal to IRMS by I average or VRMS by V average. We can write IRMS by I average or VRMS by V average. RMS value already we derived this 0.707 Imax by average value is 0. What is the average value we derived? The average value we derived is 0.637 Im. The average value we derived is 0.637 Im. We can substitute the average value here 0.637 Im it is. Now it is 1.11. How can we obtain 1.11? We can cancel Imax, both sides. Imax it is 0.707 by 0.637 gives 1.11 for sinusoidal voltage. What is the form factor of AC is 1.11. It is. Similarly, for form factor can be VRMS also. We can consider VRMS by V average. Similarly, same value, that is 0.707 Vmax by 0.637 Imax, Vmax get cancelled, then again it will come 1.11. For all sinusoidal voltages, you can form factor will be 1.11 only. That we have to remember. Next, another definition is peak factor or crest factor. Peak factor or crest factor, it is also known as crest factor or amplitude factor, it is also. What is peak factor? It is denoted by Kp, that equal to maximum value by RMS value. That gives peak factor. It is the ratio of RMS value to what is the ratio of peak factor? Peak factor is denoted by Kp. The ratio of maximum value to RMS value of an alternating quantity is known as peak factor. How can you define this? If the ratio of maximum value of an alternating quantity to peak value of RMS value of alternating quantity, that is known as peak factor. Again, what is peak factor? It is the ratio of maximum value of an alternating quantity to RMS value of other quantity. That is peak factor, crest factor, amplitude factor. That is Imax by IRMS. We know that Imax directly we can substitute Imax. IRMS value is 0.707 Imax. We can substitute 0.707 Imax. Now we can cancel Imax. 1.414 for sinusoidal currents. What is the peak factor value is 1.414, whereas form factor value is 1.11. These are the various factors related to AC quantities.